Hello. Good morning, everyone. I think we can start. Okay. Hmm, So today's class is mentioned as ArrayList. Excuse me. Today's class is mentioned as ArrayList and Switch Cases. Now, okay, I don't think we'll start with this. Let's complete the remaining part. Yeah. So first of all, yesterday we did 2D arrays. So did you all try 2D arrays? Is that done? Doubts in 2D arrays questions? And we also discussed addition, so there is subtraction to be discussed. Okay, what is to be discussed? Okay. Okay, so we'll solve questions. We'll not start with any concept. Okay, just a second. Okay, I guess you all did not get time, right? So solve 2D. So let's start with the previous one. So all the previous questions that are remaining, and then we'll see solve few more 2D arrays question. And if you have doubts from gym sections, that will pick up. I don't want to start with array list because that will be too much concepts in very quick succession. Okay. The topics on contest. So most likely, since this is the first one, you're going to get concept questions from loops, nested loops, pattern printing, conditionals, and most likely arrays. Arrays would also be there. So yeah, I'm not expecting 2D arrays, but like us, there might be, but I'm not expecting any questions from 2D arrays. So it will be there till arrays. Okay. Array is showing time limit exceed. You would not have increased or decreased this. Just check whether you have written this statement, increment and decrement operations. If you most likely if you are seeing time limit exceed, that would be the scenario, because yesterday I submitted this logic, right? I submitted this question over here. Okay. Previous permutation and swap question. Where is that question exactly? Permutation in swap. Okay, yeah, so this is the question, right? So I submitted this working fine. So there is no time limit problem over here. It is a big of n solution, right? So order and solution is completely fine, right? See. So let's start with array subtraction. So this is where we left. So let's start with there and let's complete this question first. We'll see all the previous questions that's remaining. We'll complete them and then we'll go for the next questions. Okay. So addition is done. Now we did array addition, which was comparatively easier, right? Now what is array subtraction, right? How does it differ from addition? In subtraction, what I told you that addition, in case of addition, it doesn't matter what A is, what B is, right? You could easily add them because you can add a smaller number to a larger number. It doesn't show you errors, right? It is not a problem. You can, okay. But in the case of subtraction, you cannot do that. You have to figure out which one is the larger number, and then only the subtraction can work, right? Subtraction cannot work by you cannot subtract a larger number from a small one. That doesn't work in that way. Okay. So now what we can do over here is see. So let's take. So I told you steps, right? How will you do this logic? Let's call it A and B array instead of N1 and 2. Okay. So let me write the steps first. Let's solve it here and then we'll copy paste. Okay. Let me just screen. Subtraction question tomorrow, so you can get time to solve it. Acha, how many of you want time to solve subtraction and do it tomorrow? I know you did not get time. That's the problem. Just need time tomorrow. Chalo, so we'll start with that tomorrow. Okay, so try. Okay, chalo, it's solvable, so you can try. Okay. So subtraction you all try. So so let's complete the diamond pattern then. So this is like I guess you all got enough time to let's complete this. This is one question that's remaining from the previous part. Very busy schedule for today. So can we have nested switch case? Yes, you can write a complete different switch case inside a switch case, but that's like not the purpose of switch case, right? So switch case is to simplify things. So like you would really need to write a nested switch case, okay? Because we don't want to like nest it. So that's the entire idea of switch case, should not be nested. Okay. ठीक है चलो we'll do 2D array question. ठीक है, I guess that makes more sense. So let's solve a few 2D array questions. I'll solve that. That will give you some idea about 2D arrays. Let's complete this question first. Okay. So there was a question in loops, in case of nested loops, where we are required to print a diamond pattern. Right? How many of you have doubts on this? Right? I guess few of you had doubts, and we never picked it up. No doubts. So I guess there are few. So we'll pick this. Okay. So let's complete this one and then we can go to other questions. See, I'll not take more than 10 minutes to complete this one. Okay. So see, how do you print this question? I always told you, right, in case of pattern bending. So there are two loops that's going to run. Outer loop is going to run for the number of lines. Inner loop is going to run for how many characters or how many values you want to print in each particular statement, right? So see here. So here we have like this is like one pattern and this is another pattern. Firstly, let's break it down. Why? So see, here it is increasing. So this is easy to think it as one pattern, and here it is decreasing. So this is easy to think this part as another pattern, right? So it's, if you break it down into two patterns, it would be easier to print. So in case of any large pattern, it's always advisable that you break it down into smaller patterns and then print those smaller ones. That would be always easier. Okay. So let's try to do this. So what we can do is I is equals to 1, I is okay. Now let's say for this you'll get you are getting 5, right? So you have to print 5 lines. So if n is equals to 5, so how many lines would be there in the outer loop? How many lines is there in the outer pattern? So this would have n by 2 plus 1, right? There would always be, first pattern would have n by 2 plus 1, and the second pattern would have n by 2. And would always be odd, right? If in order to print it in the diamond form, and always needs to be an odd number. It cannot be an even number. Okay. So it is 5 by 2 is going to be 2 plus 1, which is 3. And here it is going to be 2, which is fine. If it is 7, then the first pattern is going to have 4, and the second pattern is going to have 3 lines. Okay. So the first loop runs from F to 1 to F. Okay. Now let's check how many stars are we printing in each line. How many stars do we have in each line? So the first line has 1 star, second line has 3, third line has 5. What did I tell you? This will always be related to I, right? So what's I over here? So I, for I equals to 1, I equals to 2, I equals to 3. How is this related? It's nothing but 2i minus 1. Okay. So this is the relation, right? So this is the relation between the stars and the I value. So you just need to run one loop that is for the stars. So you can run it from 1, j less than equals to 2 into I minus 1, j plus plus. Done. And you can print a star. System dot out dot print star. System dot out dot print, and then nothing. Okay. Now you got the first half of the pattern, first part of the pattern, and similarly you can print the second part of the pattern. So what's the second part? Yes, I know there are spaces. Let's first print the stars and then I'll come to spaces. Okay. So what's the second part of pattern? Second part will similarly run a loop from j is equals to, so here it is. Let's check how we can print it. So we have to run this, so it will s, right? Now see, so here if we run it in the reverse order, it is going to be running from 2 to 1, right? If you just think of running it in the reverse order. So why I'm running in reverse order? Because we get the same number of stars. So if it is 2, you get 2i minus 1 stars over here, 2i minus 1 stars over here, right? So 2i minus 1, the formula that we got in the first case, is also fitting over here. If you just run the loop in the reverse order, you can run it in the like 1 to 2, and then also like there would be some relation you can figure out. So let's say if this is 1, this is 2. So for 1 we are printing 3 stars, for 2 we are printing 1 star. Y plus 1, 2, 3. You'll need to then again take another variable, right? I don't think there is some easy calculation that you can do over here. But if you take this as 2, 1, this would be easy. 3 stars and 1 stars, which is nothing but 2i minus 1, same formula that we got above, right? Done, right? So see, now same thing we can do over here. I is equals to 1. I is less than equals to s, I plus plus. Okay, sorry. I is equals to s, I greater than equals to 1, I minus 1. That's it. We're just running this loop in the reverse order, and then we can do the same thing that we did over here. 2i minus 1 stars we are going to print, right? Now if I run this logic, what you're going to see, there is equal number of stars that we got the stars. See, 1, 3, 5, and then 3, 1. Only thing that is missing is the spaces, so that we can add. Okay, first you tell me how many of you got this. Any doubts over here? So first loop is printing the first part of the pattern, which is having 2i minus 1 stars. The second loop is printing the second part of the pattern, which is having 2i minus 1 stars again, right? Here just that we have running the loop in the reverse, and here we are running the loop in the forward. That's it. Here we are increasing, so we're running the loop from 1 to f, and here we are decreasing, so we're running the loop from s to 1. Okay. Okay. Done. So now what's remaining is the spaces. So now we need to figure out how many spaces do we need to print. So for spaces, what we can do is, for int k is equals to 1. Similarly, spaces would be related to I. So let's look at the first one. How is spaces related? Here, the spaces 1. This is 2. So for I equals to 1, the spaces are 2. For I equals to 2, the spaces are 1. The I equals to 3, spaces are 0. So how is it related? It is nothing but whatever is I. Okay, so n is 3, right? It is n minus I simply. F minus I here. Yes. And we can do I plus plus. We just need to print these many spaces. Done. So if I run this, you'll see the spaces in the first part of this pattern. Actually, less than 1. Sorry. Okay, see, so the first part of the pattern is correct, right? So here I told you, right, these relations will always be, this was an exception where you got a relation of 2i plus 1, 2i minus 1. But most of the time your relations would be something like this: I plus 1, I minus 1, I plus 2, I minus 2, n minus I plus 1, right? So these are the relations I told you, right? So you can figure out this. In some cases it will be 2i plus 1, 2i minus 1. These kind of relation will also be there, right? Yeah, I'll explain about test case. Test case is nothing, no problem, right? Okay, now let's look at the second one. So here the spaces for I equals to 2, it's 1. For I equals to 1, it's 2. That's the same n minus I spaces, s minus I. So s is 2 to 2 minus, okay, s, no, it's not s minus I. That is s minus I plus 1 hoga side. So see, here I is equals to 2, here I is equals to 1. So here we are printing 1 space, here we are printing 2 spaces, and the s is equals to 2. So it is s minus I plus 1. check. So it is s minus I minus s 2 minus 2 is 0 plus 1 is 1. 2 minus 1 is 1 plus 1 is 2. Right? Done. So I guess this is it. So you can write for loop k is equals to 1, k is less than equals to s minus I plus 1, k plus plus. Run this. Okay, done. For this, how many of you understood it? Any doubts on the spaces part? The first iteration, we just figured out that the relation is f minus I, right? Similar to n minus I. And here the second part, we had like spaces is s minus I plus 1. That's it. Okay. Once you got these two logics, so this entire logic is fine. You can copy this. You can go to the portal. So this was there in nested loops, right? See now, in this question, like these things are fine. There is nothing that's given. Oh, chalo, interesting. So see, in this case, everything is fine. Only just what is the thing that is asked to you? That what is the input? So first line of input is containing test case, and second line of input is containing a n denoting the height of the pyramid. That's fine. So I've written this logic for like if we have any n, then we can run this logic and it would work fine, right? So let's say if we just write sc dot next end, and this logic is going to be fine, right? We need to write a scanner as well. Okay. Also, are there any spaces star? Okay, so there are spaces in this pyramid. What did I tell you how to handle spaces? So you don't need to do them in the initial calculation. At the end, if there are spaces in between the patterns, you just add one space over here and you increase the space over here. You just add one space over here and you increase one space over here. You don't need to change your calculation. You don't need to do anything for handling those spaces, right? Those will automatically get handled. Just add one space over here and one space over here. That would be fine, right? So you don't need to take care of them in the initial calculations because these calculations will become a little bit more 2 times this plus minus 1. Those scenarios will be there. So instead of doing those, right, you can just handle it without spaces and then add a spaces at that. Okay. Now, what is this test case? So test case is basically telling you, let's say if you are given 3 and then 3 numbers like 2, 4, 2, 4, 6. Okay. So what you should print is you should print 3 patterns, one of the size 2, one of the size 4, one of the size 6. See, the first, so we gave 3 inputs, 2, 4, and 6. Okay, sorry, 2 cannot be an input, right? It has to be odd number. So let's say 3, 5, and 7. So we gave 3 inputs, 3, 5, and 7. Yes, input should be odd. So if we get 3 inputs, 3, 5, and 7, so it is printing a pattern of 3 size, then a pattern of 5 size, and then a pattern of 7 size. See? So so this is just how many patterns you have to print. If you are given 3 inputs, 4 inputs, so that many patterns you need to print, right? So here, what you need to do is you just need to take this t is equals to sc dot next end. And what you need to do is you need to run this logic t times, right? So the like one way that how can you run something t times. So let's say this is equals to 1, p is less than equals to t, p plus plus. Done. So now this entire logic is going to run t times, right? It's same, right? So here there are 3 patterns where there are like So see, so here what we have done is we have to take input every time. Yes. See, so inputs and outputs are different, right? In case of this logic, you can take all the inputs while printing the output as well. So see, as I know while loop is simpler, let's first understand this what I did. So in case of test case, right, you don't need to like first take all the inputs and then you can print. You can just take one input, solve the problem. So here, for example, when I want to print the patterns with 3 stars, I don't need to know what the other patterns are going to look like. So I can see what I did was I took the test case input, which is fine. I took how many times I need to take these inputs. So I ran a loop for t times. Now what I have to do for each of these t times? Each of these t times, I'm just taking a ns input and I'm running this entire logic. So this is how you handle test case. What you need to do is you need to just uh, take another input, right? For each test case, that is an independent input. It is not dependent on anything else. So once you take this input, you just can write the entire logic that this is what how you are going to print out pattern with the value n. Okay. Next one, the loop completes, right? So you are going to take p is equals to 2. You are going to take another input, right? And you're going to print that pattern. So you are basically taking 5 input and you are taking the printing that pattern. So basically we have started printing the output without taking all the inputs, which is fine. Okay, that is not going to be a problem in any compiler. So you can print, you can start printing outputs and and meanwhile you can keep on taking inputs as well. Okay. Now if you submit this, this is going to be this is going to get should be fine. Yes, I guess. Okay, clear? Now here, there is how many of you understood this doubt here, right? So basically, you can keep on taking inputs and you can print it, right? So you just need to take one input, and this is how you'll handle any test case scenario. If you're given multiple test cases, multiple test cases are basically multiple inputs to solve the problem, right? Multiple inputs for which you have to solve the problem, same problem again and again. So you just need to keep on taking those inputs and solve those problems independently. Now this loop, like this for loop, no one writes it this in for loop. There is a shortcut to write this. Write this in this way. Okay. So this is written in this way, much cleaner, easier to write. Right, a very shortcut to write this entire loop. So what we are doing over here is see. So we are doing T as post increment. Right, and this should be post increment, not pre, because if you do it pre, the loop will run one lesser time. If you do it post, it will run for exactly t times. See, so I've taken t as input, right? So don't need to take any other variable or create any loop iterator or something. So what you need to do is you just need to write t minus minus. So the 0 is by default a false value. So the numeric value 0 is by default false. Okay. So whenever it will reach to 0, your loop will terminate. Okay. So the numeric value 0 stands for false value. Okay. So that's why this loop also works fine. What is this? Let me just run this. Not false. Does it require typecasting over here? I don't think it should be there. Okay, you can then if it doesn't convert, but it converts in most other languages. So I'm assuming that it should be converting. No, it cannot be converted here. Okay, so you can take this condition instead. If this is not working, then you can take t minus minus is not equals to 0 or greater than 0. Yes, you can take this t minus minus is greater than 0. Yeah. So this should be fine now, right? If you run this, equal to should not be there, right? If it is 0, then we are done. Yeah. Okay, so it is equal. So it is done, right? If it is equal to 0, then we are done. In Java, it doesn't convert this. So that is interesting. Then okay. So this is like the same thing, but since it is not automatically converting, we have forcefully added this condition. See what we did over here. Switch just that same logic. So for example, t equals to 3 when t is, let's say, 3. So what we are going to check in the first iteration, t minus post decrement. So at that point of time, we'll get the value 3. We are going to check 3 is greater than 0. Yes, which is fine. Next iteration, it has decreased. We have not used t anywhere in the loop. So next iteration, it has decreased. So we'll check 2 is greater than 0. Yes, which is fine. Next iteration, we'll check 1 is greater than 0, which is fine. So we are running for 3 times. And the next iteration, we are going to check 0 is greater than 0. This is false. The 3 values were through 2. So we are running the loop 3 times, which is fine, right? We just wanted to run the loop 3 times. So we can do so with this in for loop decrement in the condition. Yes, you can do with this in the for loop decrement in yes, you can do it with a for loop as well. Will this will the condition, and you will have like a decrement operation separately. You're running the loop entirely for n. Okay, that's fine, right? So you have checked inside, right? How many number of columns you have to print? Yeah, that's also fine. That's also fine. Yes, OP, that's correct. Okay, understood this. So this is like how you will be taking test cases. So there is like in a lot of questions you would be asked to take test cases. Lead code doesn't do it. Lead code just gives you the functions to write. In combines like Geeks for Geeks or Interview Bit, there you see you have to take test cases. In Code Forces or Code Chef also you are given multiple test cases for which you need to write loops. So yeah. But here also for each test case, your independent time complexity is fine. So here you have to take one thing into consideration, that for each given test case, you have again the same 1 second. Okay. So for each test case, you are getting 1 second to run. So you don't have to worry about, let's say if you are given 100 test case, then will your logic work or not, right? So for each test case, most of the cases you have 100 seconds, 1 second to run your logic. Okay. So this logic you should write always logic in such a way it should be running within 1 second. Okay. So you don't have to worry about test case. That is something which compiler will handle. So in the number diamond question, how can we get 1 once we exceed 9? So number diamond question, yes, so you can exceed, like once you exceed 9, so you can use percentage 10, right? Percentage 10 should be there. So percentage 10, percentage 9 will give you 0 to 8, but percentage 10 will give you 0 to 9. Okay, you just need to do percentage 10. That's it. Clear? Let me copy this logic. Now there are variations of this. How many of you tried out the variations? So there are like basically a hollow square or hollow diamond. Yeah, hollow diamond in the assignment. There's a question like that. Did you all try that in the gym section? Yes, finished. Okay. Okay, so try that. Okay, there is a hollow diamond pattern. If you have not tried that, try that. Okay, that's going to be easy now, right? How will we know our code is running within 1 second? So like I told you, right? N should be less than 10 to the power 8, and you can see. So here how many? So here we have like what we are doing is we have nested loop. The outer loop is running for f times, or which is like almost n by 2. So you can consider this n by 2 times, and inner loop is running for 2i minus 1, which is again n. So this is a n square logic, right? N square logic. Let's check the constants. What are the constants that we are given? In the constants, it is telling n is 100. So n square logic will result in maximum 10 to the power 4 lines, which is fine. 10 to the power 4 will run always in less than 1 second, right? So that calculation we did, right? So you just have to check whether your number of lines of code is exceeding 10 to the power 8 or not. After exceeding 9, it should print 1. So you should always be starting with 1, right? Not with 0. So so you can simply do it %10, but add 1 to the result, right? %10 plus 1. Right, so you should not be starting with 0, you should be starting with 1. So you can do %10 plus 1. Got it? And initially also, I guess you would be starting with 1 as well, right? Okay. Understood. Okay. Any other pattern doubts? Any other pattern doubts? No, Nitin, there was a just chat, a doubt in the chat. Okay. Any other doubts in nested loops? So loops is clear, right? So this is something which you're going to get in contest as well. So I'm assuming this is very clear and you all will be able to solve questions on these. Functions also we understood. There was only one question, binary to decimal. This one we discussed. And I don't think there is any other question you are left with to discuss, right? All other questions are easy. Okay. Functions wise, it's done, right? No doubts over here. This question everyone solved, right? NCR. So basically you have to find out n factorial, you have to find out r factorial, divide them. Acha, how many of you did it in this way? Chalo, I'll tell you one interesting way, and this is like why there is one interesting problem that you'll face over here. So in this question, NCR, well, how many of you did it in this way? So you actually did this thing. So you found out n factorial, you found out r factorial, and you found out n minus r factorial separately, and then you divided this. How many of you did it in this way? You found this out, and then this, and then divided it. Everyone? Yes. There is someone who thought we can reduce. So you don't need to do this actually. Okay. So you don't need to calculate it in this way because why I'm telling, because n factorial can be a very large number. Okay. So n cannot be like you might know there might be a long it cannot be showed in a long or a let's say integer value. So finding out n factorial you should not do this, right? If n is a large number, you can still get the result without being able to store n factorial into a long. So for example, let's say n is 20 or n is 30. So might not be able to store its factorial in this any long value, but you can still get the result for it. How? You can reduce the calculation. How can you reduce the calculation? See, n factorial by r factorial divided by n minus r factorial. Or in simple terms, let's check for any value. Let's take it 8 factorial. So what is 8 factorial? Let's take 8C3. Okay. What is 8C3? So 8 factorial divided by 3 factorial, 8 minus 3, which is 5 factorial, right? So this is the value. Now what you need to do is, okay, so this would cancel out, right? Till 5 factorial, all the numbers would cancel out. This is 6 into 7 into 8, just, right? So you need to divide 6 into 7 into 8 by 3 factorial. Now this is lesser calculation. So you have removed completely one, you just cancelled out one calculation. Are you getting this? Now, similarly, if let's say you have to find 8C6, 8C6. So you'll get something like this: 8 factorial by 6 factorial into 2 factorial. So you need to here cancel out this 6 one, right? So you'll get 7 into 8, and you should divide this by 2. So whichever is the higher value with r or r factor n minus r, whichever is the higher number, till that you need to cancel out. So if you're running a loop for I is equals to 1 to n to find out n factorial, you don't need to do this. You can run a loop from whatever is this value, right? Whatever is this you got. So for example, here the higher value you got is which so let's say for r is 3. So what is the higher value you're going to get? You're going to get 5. N minus r is higher, right? So you need to, how will we compare between r and n minus r? Let me show you this logic. Okay. So yeah. So most of you, like most of us, we do it initially in this way. Then we realize that there is other way to do it. So see, we have n minus r. Let's find out n minus r, which is n minus r, right? Now let's check which one of them is greater, right? So let's take it as the, what we call this, divisor. Okay, let's call it, let's try to find out f divided by s. I'm trying to find out this. So the top part is going to be f and the bottom part is going to be s, right? So f is going to run from n to till what value? So if r is greater than n minus r, sorry, n minus r, then we are going to use r. Otherwise, we are going to use nr. Okay. And second part is like same logic we can apply over here. Second part is if r is equals to, if r is greater than nr, then we are going to use, then we are, so if r is greater, then r will cancel out r, right? So we need to use nr, otherwise we need to use r. Okay. Tell me how many of you understood this. Let me write the complete logic, right? Firstly. So let's find out the int factorial 1, which is 1, and factorial 2, which is 1. So this loop is going to run from f2 less than equals to n I plus plus. So 8C4 you can do it with anyone, right? You can cancel out anyone and you can find that, still find the result system. Okay, we need to return. This is going to be long. Oh, sorry. Everything 30. So let's check. Let's validate what's wrong. So see, what we're trying to do is, so let's say if it is 5C2, right? 5C2. So what we need to do is, first will be 5 factorial by 2 factorial divided by 3 factorial. We need to cancel this out, the higher value out, so that we need to do less number of multiplication. So you just need to find 4 into 5. So for that, what I've taken this f variable. So if r is greater than nr, so what is r? Minus nr. nr is n minus r. Right. So if 2 is greater than 3, is it true? No, this is not true. So we are going to take nr, right? So you are going to take nr. Okay, instead we should take it nr plus 1 and or r plus 1. Okay. So we okay. So what we are taking is, we are taking this as nr plus 1 or r plus 1. So in this situation, we'll take, is this true? No. We are going to take nr plus 1, which is 4. So we are going to take f is equals to 4. F value will be 4. Now check over here. What we are going to do with this. So we're checking again, 2 is greater than 3. It is not. So we are going to take, so this is false, right? So we are going to take r in this situation, which is 2. Okay. Now check what we are doing. So first loop is running from 4 to n, which is 4 to 5. And we are trying to find out 4 into 5. So for this is finding out 4 into 5. Okay. Second loop is running from 1 to s, which is 2. So we are finding out 2 factorial, 1 into 2. Just fine. So this is what we need to find out, right? 4 into 5 and 2 factorial, and we need to divide them. Right. Now we are getting both the results. We are dividing them. Let's check. Okay, we are getting 10. I should submit this. N will always be greater than r, right? In order to find any NC, r you need to, n will always be greater than r. That's given, right? Understood? So I just reduce the number of calculations. This logic might look a little bit complicated. Sometimes writing complicated logics is fine, right? Because we are reducing. So here, see, we are still finding only 1 factorial, which is like the smaller value among whatever is the smaller value between r and n minus r. We are finding out that factorial, right? Which is this s. Okay? whichever is the smaller between r and n minus r, we are just finding out. So if r is greater than n minus r, then we are finding out. So the smaller one is nr, so we are finding out n minus r factorial. If r is smaller, then we are finding out that. Okay. Now here, if what we need to do is which one is the greater value, we just have to remove that. So if r is greater, we just can remove that part from the n factorial. So if let's say r is so we are finding out n8c5. Okay. So r is greater than n minus r, 5 is greater than n minus r, which is 3. So this is true. So we want to remove 5 factorial. So 8 factorial, this is divided by 5 factorial, 3 factorial. So you need to remove 5 factorial from this, and you will be left with 6 into 7 into 8. So how can you remove 5 factorial? You just need to start a loop from 5 plus 1, which is 6. So that's why plus 1 over here. Why did I do plus 1? So just to remove, so when you're removing 5 factorial, or you want to find out 6 into 7 into 8. So that's why I did a plus 1. So your loop is running from now 5 plus 1, which is 6, to n, which is 6, 7, 8. Got it? And we are finding out that product. So we are just finding out 6 into 7 into 8 instead of finding that entire n factorial out. Okay. Now this will work for even larger numbers, at least some large numbers. So n is given as 20, right? So for 20, I don't think there will be some problem. But for some, like even if you go a little bit larger than 20s, your values might still work. Okay. Yeah. Okay. Done. Any other question? I don't think the other questions are very easy. There is nothing like to check. Frequency of digit, count of digits, all those things. Acha, frequency of digit, did you all do this? How did you do this? Iterated through the number multiple times. So to each digit you counted how many times it is occurring. How did you do this? So you're given a digit. So if you are asked to count the frequency of each digits, so in this question you're given a digit, I guess. Yes. You're given a digit, you need to count the frequency. This makes your life very easy, right? This is very easy. But if you're given to count the frequency of all digits in a number, you know how to traverse through a number. But if the question that is given is count the frequency of all the digits. How will you do this? Count in array. Counting and eliminated the counted number. Now, like eliminating is a very big problem in your numbers, right? If let's say this is the number, so eliminating this digit 3 from here is going to be a very big problem. You need to find out this part, you need to find out this part, and then you need to eliminate, right? Think little bit smart, thoda smart socho. Let's say you have to print the frequency of these digits in the sorted order, like from 0 to 9. What is the frequency of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? If it is like if the frequency of any digit is 0, so for example 0 is not present over here, 1 is not present over here, so you don't need to print them. You just need to print the frequency of those digits which are not 0. How will you do this then? See, in any given such questions, right, if you already know what is the things that you have to count, what is the thing that you have to count? You have to count the values 0 to n, right? 0 to 9. So what you can do is you can run one loop that is going to run from 0 to 9. Okay, you're running one loop from 0 to 9. Now inside this loop, you can iterate through this number and count the frequency of the digit. You can iterate through the number and count the frequency of that digit, right? So for example, when this loop is running for the first time, your I is 0, so you need to count how many times 0 is there. When this loop is running for second time, I is 1, you need to count how many times 1 is there, and so on. Like how you count for a normal number. Okay. Now, once you count the frequency of any k in the given number, you just need to check if that count is equal to 0, you don't need to print anything. If the count is not 0, just print it. It's always, you will get the result in the sorted order. You don't need to sort it. You don't need to store it in any array. You don't need to do any additional overhead. Understood? Thoda sa smart, right? Sorting, you avoided taking array, you avoided taking you avoided doing the sorting, so all the operations are avoided, right? You don't need to do anything over here. Okay, so थोड़ा सा smart सोचना, नहीं समझा? देखो, so what I told you, right? The question is telling count the frequency of digits, how you have to print and print them in sorted order. Like frequency of 0 will come first, 1 will come second, 2 will come third. So one way is like you go on counting like 7 है तो 7 का frequency, and you should not print the frequencies of those digits which are not there. Okay, so you don't need to print the frequency of those digits which are not present in array. So one way is you'll take the first digit, you'll count the entire frequency of it. You'll take the second digit, you'll count the entire frequency of it. Or you take a array, store this frequency. There are like other ways which might, which is also correct, but you need to do a lot of overhead, right? Take arrays, sort them. So all of them are painful. Instead, what we can do is you can take a loop which runs from 0 to 9. Now, here the question is very simple. You just need to count the frequency of any I. So let's say you're given a I, you just need to count the frequency of that. That's it. That's the only thing that is asked over here. If you are given any I, you just need to count its frequency. Okay. So for any given I, you just need to count its frequency, and it will automatically just print it in the sorted order, right? Because you are counting from 0 to 9. So if the count is 0, you don't need to print it. If the count is 1, you just print it. If digit is equals to I, then you need to count for it. You print it. If digit is your digit is like the digit that is that you have to count is equals to I. Okay. It is very easy. Yes. Now think it in this way. So these are like few things that you will like if you try to sort, see, taking arrays, sorting, those things are like everyone will get the idea. But if you just solve this in little bit smarter ways, now in interviews, this is going to leave a very good impact in the mind of interviewer. Why? See, when you're solving it in the portal, when you're solving it and submitting assignments, there it doesn't matter. These things doesn't matter how you're solving it. If you're getting the correct result, the code is correct. But in interviews, interviewer also see who is writing a good code, who is writing a cleaner code, right? Whose code is easy to understand. If you write something like this, it would be so easy for me to look and understand. When you take array, it would be a little bit pain for me to see, okay, this is like how you're doing. That's fine. I'm not telling you will get rejected for it, but this would also give you additional time to solve more questions. So you have a fixed time, 1 hour to solve 3 questions. Now, if you save questions in some time, you can definitely use that in the harder questions, right? So why to waste your time on the easier ones? How to write so that we don't need to wrap it later. That means on this particular question. Acha. I don't get that question, Nitin. Any question? Acha. So see, like these things will Acha, code got unorganized. So for example, let's say if you are not first thing should be getting a solution. Okay, you can think of this better solutions and it will gradually come over time. Okay, I'm not telling that this kind of logic will strike immediately. Nahi karega, but gradually over time, if you solve it, it should strike. If you always see 2 solutions that is striking to you, always think of one that is easier for you to explain, which is cleaner. Okay, so always go for that, and always like try to write clean codes which would be easy for you to explain it to someone. Okay, so you would generally see the code that I write is little bit easier for you to understand as compared to any codes like that you think of, you write off. So why it is little bit easier? Now I'm not telling for all questions. For some questions it is definitely a little bit easier. Why? Because I try to write it in the cleanest way, right? There can be even cleaner ways. I say sometimes, right, this is not the most cleanest way. There can be some cleaner codes, but yeah, most of the time I try to write it in the simplest way. so that you are easily able to understand it, and same is going to happen in the interview as well. See, there is like interviewer might be prepared for that question, but you might write a solution that is completely out of the box, right? So every time I solve this question with any batch, and then you share me the solution which is completely different, which I have not seen. So I again have to see through that code. Then only I understand, okay, this can be done in this particular way as well, and this is also fine, right? Okay. Do you want to get the dates as well? That would be better. Yes, that's a good suggestion. So I guess today we started from here. So we started from here. So let me add that comment. So today's date is 18th March. It anyways follows the same order that's there in your I guess portal. So in case you are looking for, yeah.
Sir, explain previous permutation is option.
Fermentation. Where is this question?
Gym question.
Okay, gym question. Can you paste that link?
Okay.
Okay. So
Okay,
arrays, sub-arrays, like any question remaining from here? Geometric triplets I solved. Yeah. So still having doubts, I did not explain it. I just solved and checked and told you that it's correct. How many of you are having doubts in this one? Solved these questions. Actually, this array too, we have not taken doubts. So all the questions from here is done. Rotate array, divisible sum, a sub-array sum divisible by k. No doubts. Reverse array. Geometric is remaining. Okay. So see here, what you have to do is you need to take 3 numbers. Okay. So what is the array size? 10. Array size is 10. So that is not a problem if you run n-cube logic. Okay. Okay. See, so what you need to do is so here what we are doing is we are given an array. We are writing 3 loops. So what these 3 loops will do? First loop will pick the first number. See, so you have to pick 3 numbers, right? So every time you need to pick any set of numbers, you need to write that one loops. So first loop is picking the first number, which is 1. 1 is fixed. Now the second loop is picking the second number, which is 2. It will vary from the second number. For 1, what are the second numbers can be? So 1, 2, 1, 6, 1, 10, 1, 18, 154. So all these are valid second numbers. So basically, if I is your first number, any number from I plus 1 to n can be the second number. Okay. Now, let's say you got the second number as well. Now you need to pick a third number as well. So let's say if your 2 is the second number, so what can be your third number? So third number can be 6, can be 10, can be 18, can be 84, can be 54. So what you can do is so you can check for, let's say this is j. So you can check for j plus 1 to n. So if j is over 2, so your third number can be, so if j is 2, your third number can be from your third number values can be 6, 10, 18, 54. Now check. So did you get all the possible combinations starting with so 1 to 6, 1 to 10, 1 to 18, 1 to 54. You got all the combination, right? 1 to 6, 1 to 10, 1 to 18, 1 to 54. Now similarly for 1, 6, if this is your second number, what can be your third number? So your third numbers can be 10, 18, 54. So now you got all the combination 1, 6, 10, 1, 6, 18, 1, 6, 54. So you got all the combinations for 1, 6, all the numbers that has 1, 6 as pair, right? 1, 2, 6 you already got, right? So you already got 1, 2, 6. Now you got 1, 6, 10, 1, 6, 18, 1, 6, 54. Okay. Similarly, you'll get for other numbers as well. Now, first of all, we understood this 3 nested loops, why I have taken I plus 1 and j plus 1. Now, what is geometric triplet? Okay, that is out. So a geometric triplet is basically, so you have to pick 3 numbers from the array such that they are in a geometric progression. So they are in a geometric progression. So what is a geometric progression? So there are 2 types of progression. One is arithmetic and one is geometric. Okay. So one is a arithmetic progression and another is a geometric progression. So what is arithmetic and geometric progression? So a geometric progression is basically okay, so let's say this is a geometric progression 2, 6, 18. So you just need to divide 18 by 6, you are going to get 3. Same thing, if you divide 6 by 2, you are going to get 3. So if you divide any 2 consecutive numbers, you are going to get a ratio. This we call as a common ratio. They have a common ratio. And divide any 2 consecutive numbers, you get a common ratio. What is arithmetic progression? In arithmetic progression, any two numbers in the series differ by a common difference. Right? So if you subtract 4 minus 2, you're going to get 2. 6 minus 4, you're going to get 2. Right? So that is known as common difference. And this is what arithmetic and geometric progression is in gist. So for arithmetic progressions, you have a common difference. For increase for a common like geometric progression, you have a common ratio. So there are multiple ways to validate when there are three numbers. First, it will be understood. No one having doubts on arithmetic geometric progression. This was there in standard 10, right? I don't think this was there in my ICSE syllabus, but this was there in CBSE syllabus. It might be there in state boards as well. So now, yes, I've seen the question. I've seen few questions links in the chat. So I'll pick them up. Okay, just a second. So see, so what we are doing over here is, so instead, let's say you have A, B, C, and you need to check they are in geometric progression. So you will say check C by B is equals to B by A. And common ratio can be also a decimal number, right? Because this can give you decimal. So this can be even 1.5 and this can be also equals to 1.5. This is fine. You can get a 1.5, 1.8. If you're getting the same common ratio, they are in geometric progression. So either you divide it and you check for double, which I've done over here. So what I did, I divided A of K by A of J, and like doing that double conversion. So I get the common ratio double, and I divided A of J by A of I and divided it into double. So I get the correct common ratio. Now, if they are equal, right, this first common ratio J divided by, so B divided by A is equals to C divided by B. If this is true, then this is our, like these three numbers are in a geometric progression. This is one way, or you can write it in this way, right? You don't need to handle that double situation. You can write it in this way. First number into last number is equals to this B into B. How? So you just need to cross multiply, right? So if you, so what is our condition? So we are writing this, right? So you can check C into A is equals, should be equals to B into B. This should be equal. If this is fine, then your numbers are in a geometric progression. You can check it in this way as well. That is also fine. Okay. So this is also fine. This would also submit. Here just that we are converting it to double and doing that. In order to just avoid this double calculations, what you can do is, okay, submitted. In order to avoid this double calculations, what you need to do is you can simply do this. A of K into A of I, and this should be equals to A of J into A of J. Okay. And this should also be fine. How many of you understood? ये new logic समझ नहीं आया? So see here you are just finding out triplets, right? So for triplets you can do this. That was a generic logic, right? You can just check the common ratio for every number in the series. So let's say if I give you 5, 7, or 10 numbers, then this logic is not going to work, right? This is like a little bit difficult to figure write some logic like that. So you can figure out the common ratio between any two consecutive numbers and check whether they are same, and if it is like the same, then you can say okay, that is fine. But here, since you are given only three numbers, so you are checking, let's say A, B, C, so your common ratios are going to be C divided by B and B divided by B. These are the common ratios, or you just need to check whether they are equal or not. So what you did, instead of checking this, so let's say this is 2. So you can, instead of checking this like 6 divided by 2, which is 3, 18 divided by 6, which is 3, you can check this 18 into 2, which is 36, and this should be equal to 6 into 6, which is 36. Okay, this should be equal. If it is equal, then these three numbers are in a geometric progression. This will hold true for any three numbers in a geometric progression, that the you multiply two numbers in that series, and that will be the product of the middle numbers. Right? So if you have three numbers and you have to check whether they are in geometric progression, so you can do A into C. This should be equal to B square. Okay. Is there any way to optimize it? Actually, there is a way, but that would be like using hash maps. Uh, we'll reduce to -1 using ChatGPT. Yes, yeah, there is a hash map solution which can optimize it, where we can find out the common ratio of two consecutive pairs, and then we can take those two consecutive pairs. We can use dynamic programming as well. I guess thoda sa dynamic programming. This is the I guess 2D dynamic. There can be a dynamic programming. There is a dynamic programming language. All those will reduce it from n cube to n square. There's no way to reduce it beyond that. N square tak reduce ho sakta hai, but all those concepts we don't know yet. Okay. Why we are learning DSA, we can do using ChatGPT. ChatGPT is not very bad at writing like complicated code. It can give you solutions for like easy DSA questions. It can write those. Now the GPT-4 is even better. It can write create a simple HTML website. But yes. So now there is like I'll tell you about a little bit insights about Microsoft. So Microsoft in this month is launching a lot of things. So this is like the March month where Microsoft launches a lot of things. This year it has been like super like phenomenal. We are seeing everywhere like there is a ChatGPT integration that is there in all the products that's rolling out. So if you follow Microsoft blogs and anything, so you would see that there is a lot of products that Microsoft is rolling out with ChatGPT and all the other companies as well. There is one co-pilot that Microsoft has rolled out in a lot of products, which is basically you get a chat GPT within all the products that is named as co-pilot. Now, if you want to write something in a Word doc and you want to like get some idea, you want to write some template, you want to write something, you can just tell it to chat GPT, it will write that for you in the Word doc. Right. Or in your OneNote, or in your if you want to create a PowerPoint slide, that co-pilot is also there in PowerPoint. So it will automatically pick up one good good slideshow for you. It will automatically pick up one like content for your slide, but how you should your thank you page should look like, how your front page should look like, which we used to design, right? We used to figure out, okay, this is how my front page would look like or something. It will automatically figure one best template for you. Do that. So there is like a lot of integrations which Microsoft has rolled out this month, and those are like out for public. You'll be able to see it soon. So you need to do DSA. See, you need to do DSA. Engineers are not going to go away very soon, right? So we ChatGPT can do solve easy things, but for complicated things, we still need engineers, right, to write code. It can be like I'd say ChatGPT can be like a integration that you might see later in VS Code as well, which might be helping you to suggest while writing code, but it can never write the code that you are thinking, right? So like at least for now, right? Maybe in near future, very like 20-30 years later. It's like there is so much error. It cannot create a software. It can be a like your co-pilot. That's the best way to tell it, that it can suggest you things on the fly. You can use it as a like while writing logic. So you see, I make mistakes, small mistakes over here. Sometime I write equal to, less than, equals to. So it can immediately show me that this is an error, right? So this is an error. If I write it equal to, so it is not a. So I don't know that this is an error, but GPT can tell me that this is an error. You can think, right, this should be less than equal to or greater than equals to. Since you have written plus plus, so it would suggest this would be less than equal to. So it can be this kind of suggestions, which removes that hassle of again running the code and running the code. Okay. So here we are running the code and it looks easy, right? I'll tell you a time. So I have heard stories at Microsoft when Outlook and all the softwares were in the initial stage, right? Not in the initial, like up till very recently, like 2010, 2008, 2010. Even right now, also we have softwares that take around 40-45 minutes to build. So for example, that software is so heavy that the compilation of the software takes 40-45 minutes so that you can see something running, right? So if you want to change a small thing, right? If you just change a small thing, let's say you change this from I equals to I plus 2, just to know whether it will work fine or not, you need to run it, right? Now that running is going to take 40-45 minutes. And let's say you just like you did this and somehow like you made a mistake, you added a semicolon, you ran it. You went to 45 minutes break, you came back, you saw there is some error in the compiler that it is telling this is a problem. And then you again waste another 45 minutes running this, right? So there was no chance of making compile time mistakes. So the older Microsoft engineers they are so good. They're and they have seen the times when it used to take 5-6 hours, right? So I met with the engineer, like she used to work on Outlook, and their code used to take around 6 hours, 5 hours to compile. That was such a big repository. So that was like a very big pain for developers to run code without testing it. So that's why Microsoft always focused on engineers who will test their code 10 times running it. Otherwise, like in a single day, you will be just writing code, and if you make this compile time errors, then you are done, right? You will be just there was no there can be IDs that show you errors, right? Those were helpful. So compile time errors were compile times errors were still fine. You can look through them. But what about logical errors, right? So sometimes it happens, right? You write some logic and you need to run the code to check. The code was too large. The computer was not slow. The code was too large, and there are like codes which are still very large. Once I opened the Outlook code, and I never, once I had to work with that. It was like one very painful month for me, right? And not painful, but like it was too learning. So I saw a code that was written in 1918, that repository. So and that code is still, so there is updation, that is updation. So every day the new code is getting added, but there is code that is written in 1980. We are keep on continuing. There is code that is written by Bill Gates in that repository. So yeah, that was too interesting to see. So I was just looking who has written code in this repository, who has written code in this repository. So that was like so interesting to see. Yes. Okay, so let's see previous computation in a swap. Okay. Runtime exceptions we cannot dictate, right? So for those things, if you make errors like that, you will have to again rerun it, build it, wait it, right? So now it has improved. So they have reduced it to 40-45 minutes, but earlier it used to take in hours. And but 40-45 minutes is still very painful, right? 40 minutes, what you'll do. So the code that I work on used to take 20 to 30 minutes to build, right? Around 30 minutes. And it was a year ago, right? It was not like too back. I'm talking about a year ago. Now there is everyone was worried. Every engineer thought of what we'll do. We'll brainstorm for like months, and then we came up with every time everyone came up with a solution, but that was not working for every time. And then finally we wrote something that is now working. So now we get like a build time of around 10 minutes or so. Okay, so now it take around 10 minutes. So we have reduced from 30 to 10 minutes. 10 minutes is fine, right? 30 minutes is like not fine. So yeah. How did that happen? So we changed internally how the things that we used, right? So you're going to see the product that I built very soon. So today is 18th, right? So 22nd, you're going to see the product. So that's a public preview. It already has been launched, but you'll see it for yourselves on using it, right? So I'll talk about that in the end. I'll tell you more insights about what's working at this, right? What the day-to-day job looks like. That's already there, right? So there is like nothing to disclose it. That's already there. People have registered for it. You can even register yourself for using it. That's there. The site is up, right? It's just that you will be able to use it after 22nd. Right now, you can join the wait list if you want an early access. So there is a wait list that's going on. So, okay. The site is this. So you'll see a site like this. You can try to get early access. So since I'm signed in with my Microsoft account, I can directly sign in and start using it. But you for like other accounts, you would need a early access. You might see a waitlist kind of thing over here, if you're not seeing a sign in. So this is like a collaboration platform where multiple users can collaborate simultaneously. You can write it. So just loop.microsoft.com. That's the URL is simple. You can just, it's loop.microsoft.com. And this is going to be one of the latest addition that you're going to see in your Office suite. Right? So Microsoft Office is not going to have this thing known as loops. And this is like the most advanced collaboration platform that's there right now anywhere, right? So there is no other platform which is advanced than this. This is like the most advanced platform that exists. Okay. So okay, so I'll talk about it. That will give you idea, right? How working it, like how we solve, what are the challenging problems we get, right? How we solve it, why DSA is so important, right? How DSA knowledge helps there, right? Don't you like optimizing that build time from 30 minutes to 10 minutes would have required a lot of DSA effort, right? So that yeah, so that things I'll talk about. So let's start with this question. Let's take a question from chat. Okay, so I think we are done with functions. We are done with nested loops. So I don't think there is any other doubts, right? So geometric triplets also done. Okay. Now 2D arrays question, what you all want to do. So I'll solve a few of them. Okay, I'll solve a few of them, few more questions so that you get the idea, and I'll give you some more time to solve it. So I solve rotation by 90 degree, find a way, maximum minima is there. Okay, past question. Okay, so let's check this one. Okay, there is one question that's there in chat. So let's discuss this one. Yes, Pascal triangles will solve, right? So Pascal triangle is interesting. That is an array question. Can you paste the link of that in the chat? I don't think that's there in assignment. Yes. Is it there in assignments? I guess so. Okay. No, where it is? It's not here. Array 2. Where is the new assignment? In gym it's there, right? So that's what I'm telling. It's not there in assignment. Assignment questions I remember now.
In ArrayList, so in ArrayList assignments.
ArrayList assignments. Okay. So I got this. Okay. So we'll solve this one. This is interesting. This is very interesting. Okay. So let's see this question first. So what we are asked to do over here, we are to get previous permutation in a swap. So you are given an array A consisting of n integers. You need to find its previous permutation that can be formed in one swap. Okay. So formally, you need to find the lexicographically largest permutation that is smaller than A. Acha. So you have to find out the lexicographically largest permutation that is smaller than A. If the answer does not exist, then return the unmodified array A. You need to complete the function inputting printing. So I remember this. This is like there are a lot of edge cases in this question. Otherwise, fine. So here, like so you have to find out a lexicographically smaller number. Right? Actually, lexicographically largest permutation that is smaller than So you have to find one smaller permutation than it. So this is the smallest number that can be formed, right? So let's say this is one number. Yes, I'll tell you what this means. So let's say this is so let's say you have a number. Okay, so what this question is simply telling, forget about this. Let's say you have a number. Okay, 452. Okay, so this is the number. Now, what are the three digits that you are using over here? 4, 5, and 2. So what are the so let's say there can be multiple combinations of numbers that you can make with this. So you can make 4, 2, 4, 5. You can make 4, 2, 5. Right? There are multiple combinations. You can make 2, 5. Sorry, 2, 5, 4. So there can be so many combinations that like you can create, right, with three digits. With these three digits, you can create multiple combinations. Now, what it has asked, let's say if you put all these combinations in the sorted order. So let's say how many combinations we can make with these three digits. You can make 6, I guess. This will be the first, then this will be the second number in the sorted order. Then this will be the third one. I guess 4, 2, 5, 4, 5, 2, and then you have 5, 2, 4, and 5, 4, 2. Yes, so these are all the 6 numbers that you can create. Out of this 6 number, which number is this? This is the number that you are given. So you have to basically figure this number out. So you have to figure this number out. That's your answer. Okay. Okay. So for any given number, so you are given any combinations among these. So if you are having 3 digits, you're giving any combination among this, and you have to figure this number out. Now here, like it is simple swap of these 2 digits. Okay. How it will work for any larger array? Think. So what is going to be the previous number in this? Let's say this is the given array. What's the previous number in this? Tell me the answer. सोचो थोड़ा सा answer सोचो. You'll get the idea. Then yeah, so in this like in this particular thing, what should be your answer? So the answer will always be smaller than this. The answer should be always smaller than this, right? Because see, you are just shorted in, so this number always will be smaller than the next one, right? So this number, previous number, is always smaller than this. Yes. So what you have to do is, see, you just have to pick this digit. You have to find out your traverse. You have to traverse towards left. You have to find out a digit which is larger than this. Okay. So this particular digit is larger than 3, right? So larger than 3. So you just need to add 3 over here. So final result will be 4, 3, 5, 1, 2. This is your result. Or I guess 5 to 1. You'll have to reverse this. The remaining parts you'll have to reverse. So this part you have to reverse. The numbers that are smaller, you'll need to reverse. You'll get 2, 1. So this is the digit, I guess. 4, 5 to 1. Yes. So this is the largest combination that you can make with this. And after this, the next combination, all the other combinations are smaller. The next combination is going to be 4, 5, 1, 2, 3. Yes. Okay, so there are few operations that we need to do over here. Now look at it very carefully. Okay, so I'll break these operations down. So don't look at this one. You won't be able to see all the operations. Look at this number. So what is the combination? First, tell me, is this the combination correct? I think we should be getting this, right? Which is fine, I guess. After this, the next number that you'll create, you cannot create any. Is there any number in between that you can create between this and this? No. After this, the next number that you'll be able to create is this. Or is it so? You have 4 as well, right? So there is 4 as well in the number. You can create 4. So 3, if you take 3 in the start, that is smaller, say 4 starting. Yeah, this is like okay. Okay, so how much you understood the question, how much you didn't, why this is the solution for this one? Let's also check it here. I guess this should be the answer. So we have 1 test case, you have 5 inputs, you have 4, 5, 1, 2, 3. You can validate this using expected output. This should be. Take 4, 3, 1, 2, 5. That has not reversed this. They're telling lexicography. Oh, okay. Sorry. It is not telling it in the lexicographically large. So, okay. So you don't have to compare them in this. You have to compare them in strings. Okay. You don't have to tell. So this is like the largest permutation in the number wise, right? It is not actually the largest permutation lexicographical wise. So lexicographically, the largest permutation would be not to change this order. No, actually it is. So you just need to do this then. Okay, बस यही करना है. See. Okay. Let me explain you again. Right. Let me explain this part. So this was the number. Let's take 4, 5, 1, 2, 3. Okay. So this is the number 4, 5, 1, 2, 3. So what the solution of this is going to be? So see what it is telling. Yes. Okay. I'll repeat the question. See how. Okay. Let's say there is some explanation that is given for this. Okay. See. What you need to do is, so you need to find out a previous number, which is like, this number is definitely going to be smaller than the current number. Okay. So what is the previous smaller number as given the current number? So if let's say you are given this current number, what is the previous smaller number? So the previous smaller number is, it is telling the previous smaller number is this 1, 2, 5. Okay. But ideally it should be 5, 1, 2. It is sorted in the order. Practically this should be Then let's say and then this. बहुत सारे combinations बन सकते हैं. Yeah, I guess there is some mistake in this question. Yeah, let's. I'm just trying to get how it means this is the lexicographical order, right? So ideally this should be the lexicographical order. 5. So in the lexicographical order, this number will come first. So lexicographical is the dictionary order, right? So, acha. So if you put these numbers in the dictionary, what's the order you're going to see? This is going to be your first number. This is going to be your second number, right? This is going to be your third number. You just compare these two. Where it is non-matching, this is like going to be that. You compare these two. This is non-matching, so this is going to be the second. You compare this, so this is non-matching, so here it is going to be greater than this, right? So this is going to be a dictionary order, and then 5, 1, 2 is going to be far below this because this is not matching. So this is anyways greater than these numbers are greater than this. I don't know why it has told. There is some mistake in this. Ideally, the answer should be this 4, 3, 5, 2, 1, right? So this should be your answer ideally, right? If it is sorting in the lexicographical order, lexicographically largest number smaller than this, it should, the answer should be this. This should be your answer. The compiler is telling this is your answer, which is incorrect, right? So the compiler answer that it is telling is incorrect. So yeah, yeah, I'll check the editorial as well. Okay. Let's. So for this solution, it should give this as an answer because this is the lexicographically larger number as compared to this, right? And this is like in between these two numbers. So what basically it is telling, see, I'll tell you, I'll just simplify this. Vishnu, you can like watch the recording, right? That's, you always have that access. So let me explain you this. So basically you are given a digits. You can consider it that you are given a list of digits, right? For example, here you are given 5 digits. Okay, here you are given 5 digits. So now, like here you are given 5 digits. Now what you need to do is, yes. Okay. So you are given 5 digits. Now you need to, what you need to do is, you need to figure out all the combinations of these digits. All the combination of these digits, you need to figure out all the combinations of these digits. And you need to, let's say you figured out all the combinations of these digits. What you need to do is, you need to then try to like write them in the sorted order. Right, sorted order, that means lexicographically sorted. Numbers are all automatically lexicographically sorted. So if you put numbers in the, or like its original in the ascending order, so ascending order of number is the lexicographically sorted order. So the ascending order of number is by default the lexicographically sorted order. Okay. So ascending order of number is lexicographically sorted. You can compare this, right? So basically your ascending order of numbers is the dictionary order, right? So lexicographically sorted means it should be in the dictionary order. Okay, that's what lexicographically sorted means. So if you are asked to place these numbers in a dictionary order, what should be your, how will you place them? So your numbers will look like this. Okay. Let's say if I give you these two values, A, B, and C, B, A. What's the dictionary order? Is this the correct dictionary order of this? Will these numbers, will these alphabets also lie in this particular dictionary order? These three words. This is correct, right? Achha. If I give you if I give you a like number, let's say if I give you 3, this is the dictionary order, right? If you just place in them in dictionary, this is like the correct dictionary order. Firstly A, then you get AB, then CBA. Yes, this is fine. Achha. Now if I give you a string, let's say ABC, and I tell you to find out all the combinations of this ABC. So you'll get ABC is one combination, ACB another combination. You'll get BAC, BCA, CAB, CBA. Are these all the combinations that you can get? And is this in the dictionary order? Is this in the dictionary order? Yes. Okay, clear. Now here what you need to do is see. Okay, so this is the dictionary order. Actually, in this question, wording is different. I'll tell you that this what this question is asking. Right. So you understood what dictionary order is, right? So it is asking lexicographically sorted, which is nothing but the dictionary order. What is dictionary order? Dictionary order is basically any, like if you are given a list of strings, list of numbers, if you put them in dictionary, if you are asked to put them in dictionary, the order in which you put them in the dictionary is known as dictionary order, or it is also known as lexicographically sorted. So a dictionary is lexicographically sorted. We tell that a dictionary is lexicographically sorted. And this you all know. How will you sort this? So how is this lexicographical sorting work? See, so if you are, let's say, given A, B, C, and you are given A, B, C, D, and you are given A, D, B, C, which one is going to come first in the dictionary? Yes, I'll show it with numbers. Just understand it. Alphabets, numbers are easy. Same logic. ABCD, how did you all came to that solution? How did you all come to the solution of why ABCD is coming first? The first character is matching A and A. The first character A and A were matching. So what you did, when the first characters are matching, you automatically compared the second characters, right? You compared the second characters. Second character B was smaller, so you told that ABCD will come first and then A, D, B, C. Okay. If I give you another string, if not this, let's say if I give you this string, A, B, D, E, which is going to come first now? ABCD. You will compare the first character, you compare the second character, you compare this character, whichever is not equal, you place them in that order, right? This is how we are used to keep on sorting things in the dictionary order, right? This is how we find out the dictionary order. Okay. Right? Yes, no? Clear? So now same thing you had to actually do for this, but here in this question now it has there is one catch that it has not asked you to do so many things. Okay, it has not asked you to do so many. Let's say this is the question. So it has simply asked you just swap these two values. See, ideally this is not the correct dictionary order. This is not the correct lexicographically sorted order. So if I go by the wording of the question, this is not the correct solution. Right? This is not the correct solution. The correct solution for this problem is what it has told, the largest. Just see the words. It has told the largest, lexicographically largest permutation that is smaller than A. So lexicographically largest permutation that is smaller than A is this particular number. So if you find out the lexicographically largest permutation, so it is going to be this 4, 3, 5, 2, 1. So this is the lexicographically largest permutation which is smaller than A. Okay. Yes. So this is actually, this should be the actual correct answer, but as per this compiler, this is the correct answer, which is like doubtful, right? So I see one mistake over here in this question, but yeah, this is like, this can be solved easily. Then it, and I guess that is the logic in the other test case as well. So what it has done, it has simply see. So okay, so what it has given us a array, and what we are asked to do, we have to find out this lexicographically largest permutation. Okay, so and as per this, what you need to do, right? If you have to just find out this, you don't. So what's the step that you can do? Check for this number 4, 5, 1, 2, 3. So what you are seeing, what you need to do. So the ideal thing should be this operation. So ideal operation to find out this lexicographically largest permutation is, so you start from the last digit, you try to find out if there is any digit larger than this. Once you get a larger digit, so for example, for this, you are not going to get any larger digit. So there is no lexicographically smaller permutation than this. This is the smallest permutation you can make with this. But you find any larger digit than this in the left of it, that means this is like you have a permutation that is smaller than this, right? So you keep on start looking for 3. Is there any number which is larger than 3? You got a number. So what you need to do is, actual solution should be this. You should swap this 3 with here. You need to place 5 over here and then reverse the remaining part. Whatever digits you got in between, you have to just reverse them. Okay. So this should be your solution. But in this particular example, you are just asked, in this particular question, you are just asked to do this. You just need to swap these two values. This is your solution. You just need to swap the these two values. Why 2 gets reversed? Because 1 2 is smaller than 2 1, so you have to find out the lexicographically largest one. So this is going to be, so let's say this is a smaller number as compared to this, right? So in the dictionary order, this is smaller, then this number would come, right? And then this is the number. So if you just have to find out the lexicographically largest number, which is just smaller than this, then this is your solution. You cannot find out any permutation using these 5 digits such that you will build a number that will be in between these two, right? Which will be greater than this and smaller than this. There is no such combination you can make. And that should be your correct answer. But here in this question, it has not, there is some mistake in this. It should have taken this as an output, but it is taking this. Okay, so this is even similar. You just need to do one swap operation. You don't even need to do this. If this was the ask, then it should have told it in some other way. It should not have put this word like lexicographically largest number smaller than this. Because lexicographically largest number smaller than this is this, not this. Okay.
Sir, I think it's happening because in the question it is written using one swap.
Is it written one swap?
Yes, in the first line.
Oh, okay. That's why it has asked this. Okay. So, okay, got it. Then it is fine. Then it has given you one restriction, then you are need to perform only one swap. Then this will be the solution, right? Then fine. So if you are just performing only one swap, then okay. So you can basically skip numbers, right? So basically, if this is the number, so let's check what are the numbers in between of this. So you'll get this 3 5 2 1. So 3 1 5 1 2 3 5. No 1. You'll get 3 2 5 1 4 3 2 1 5 4 3 1 2 5. No, 1 5 2 and then 1 2 5. So there are these many combinations in between 1 5 2 4 3 1 2 5. Yes. So there are these many combinations. So this is your current number. You have to find out the lexicographically largest. And okay, the constraint that is given to you is one swap, right? So I guess here mentioned it. It was mentioned in the first line. Okay. So in this line, it has not mentioned it. Has mentioned it over here. You need to find out the previous permutation that can be formed in one swap. Okay. Both the things are contradicting each other. How will we understand this? Okay. So now that's fine. Now it makes sense, right? Why this question is asked? Otherwise, it was wrong, right? So now it has you have so many things, so many permutations which are smaller than this. You have to just find one such permutation which can be formed in one swap, right? So this is the permutation that can be formed in one swap. Okay. So what you need to do to find this out? You just need to start with the last one. You need to find out the number which is greater than this, and you just need to swap it with that. Done. You got the lexicographically such number which is larger than which is smaller than this, right? Which is smaller than this and can be formed with one swap. You cannot form any number from here to here in one swap, but they are all largest lexicographically largest than this, right? So you cannot form any number in this in the one swap. So 4 is also the largest. So you have to figure out the largest, which is just smaller than this, which should be just smaller than this, right? So the permutation should be smaller than this. So your answers should be always smaller than the number that you are given. Okay. So that's why for 1, 2, 3, 4, 5, you will not get any answer because there is no such permutation which is smaller than this. That's why in the first example, when your input is 1, 2, 3, you're getting 1, 2, 3 as output because you cannot permutate it in any way to get a smaller number, right? So there no such permutation is possible. If you start by checking last number and you try to find out a larger number, you'll reach the end of array and you'll not be able to find any larger number. But here, when you start with this, you find a larger number. And the easiest thing is, since you are allowed to do only one step, you just swap this and this value, you get the result. Okay, easy. This is a good question. This is even interesting if you are not given this restriction of one swap, right? So if you're not given this restriction of one swap, then what this question will, what's the correct solution of this question is? So this is the solution in that case. How will you find this out? Hey, I'll tell you what the variations of it. So when you're given one swap, then it is easy, right? Then it is too easy. You just need to figure out that from the end, you need to figure out that largest number, you need to swap them. Okay, so let's solve this one and I'll tell you this variation. Okay, so okay, so let's say you're given an array. What you need to do is let's find out the length of this array. And 10 is equal to a dot length. We'll run a loop that will run from n minus 1 to I is greater than 1 equals to 1. Okay. I minus minus. Why have I written I minus 1? I'll tell you that. So every a of I, that will compare if a of I or a of n minus 1, the last digit, if that is less than, or if you find like let it write in this, if any a of I is greater than this, right? So we can start with n minus 2. So we are running from n minus 2 to 0. Chalo, n minus 2 to 0 run kar lete hain. That's still start from n minus 2 to 0 and we'll check is there any a of I which is greater than this. If yes, if you find out any a of I that is greater than this, so what you need to do over here? So let's say if this is a number, we found out any a of I which is greater than this, we just perform the swap operation, right, between a of I and n minus 1. So you just take a of int of temp is equals to a of int of temp is equals to a of I. A of I is equals to a of n minus 1. A of n minus 1 is equals to temp. We swap those two values and we can break. Done. We don't need to do anything else once we find out this. If this condition never hits, right? If this condition is never satisfied, then we'll never perform the swap and we'll return the original array. So if this is, for example, this is the scenario. So you'll never find any number in this left part of the array from n minus 2 to 0, so that is greater than n minus 1. So for 1, 2, 3, 4, 5, we'll still get the same result. For any such number, you'll perform one swap. So we are just performing one swap and we are getting this result. Right now, if I submit, it should be fine. Is there any test case that's not coming to my mind? I don't think so. Let's check now. There is something that's missing. It's a very large number, it should be figured out. There are multiple inputs. No. It would be very difficult to figure this out using this. So let's check it in some other way. Oh, I swapped it with n minus. Okay, n minus 2 is fine, right? Okay, let's check what else we missed, right? So there is some edge case that is missing. So let's check what we are going to get for 1, 2, 3, 4, 5. You should be seeing 1, 2, 3, 4, 5 as it is without any swap. No, I equals to n minus 2, right? Which is fine. We will start with n minus 2. Let's check n minus 1 I. So this is fine, right? I n minus 2, we are starting with next previous number. Why will we check from n minus 1? So n minus 1 is the number that we want to swap, right? So this is the value that okay, got it. Okay. Okay, I got this. I got the problem. So you need to do this operation not once. Okay, I'll tell you what's the input that we are missing. So this is fine. There is one problem. See, so for this input 4, 5, 1, 2, 3, we saw this. So 3 is like having this, and we can just swap it with this. Okay, so this is your correct result, right? 4, 3, 1, 2, 5. This is the correct result that we should be getting, and we are getting this, right? So if I just do this 4, 3. 4, 5, 1, 2. So I got the problem where the problem is. I run this. So you see, like we get 1, 4, 3, 1, 2, 5, which is just swapping 3 and 5. Okay. Now, let's go back to here. So because this was the only number that could be formed by one swap. Okay. Now let me give you some other example. So let's say we have this 4, 3, 1, 2, 6. Okay, so let's say this is the number that you have. So for 6, you will not be able to find any such number which is smaller than this to the left, right? So for the first iteration, you will not be able to find any number to it smaller to the left, right? So what you need to do, you need to check for this value. So now for this, you will check for 2, which is the 2. So I guess this should be your output 2, 136. Let's check for this number. What should be the our output, expected output? And I guess this should be the expected output that we are getting over here. So the number that we want to check is 43126. Get expected output. 42136. Yes. See. So firstly, so what you need to do is you need to do the same operations, but for inside a for loop, right? So if the last digit is not matching, then you need to check for the second last digit. You need to start a j that is running from n-1. J is greater than equals to 0, j minus minus. You don't need to do it for 0 because 0th digit you are not going to get anything. This loop will start from j minus 1. This loop will start from j minus 1. Will go to 0. For 0 case, it automatically handles this. Instead of n-1, we can handle it as j. This would be j. And this would be j. If the last does not swap, we'll swap the second last. And if this second last swap happens, if there is one swap that has happened, we don't need to do any more swaps. So we can just change this flag to 1. We can do flag is equals to 1. And if here flag is 1, we can break. And I'm writing it very quickly. I'll explain it. Don't worry. Yes. Break. Let's now try to get this, run this. So you should get 42136. 42136, which is fine. Let's submit it. Oh, what did I miss then? 42. So for this also we are getting the correct input, correct output. Did I miss anything else? Think of any other inputs, any other test case that you think should be failing. I guess so. We have covered all the test cases that we can get in one swap. So 43126. We'll check for this. Let's think. This is interesting. There is a lot of edgy scenarios like this. So let's take 1, 2, 3, 4. So for this, we should get 1, 2, 3, 4, which is fine. None of this will satisfy, right? So if I have it as 1, 2, 3, 4, 5, we are still getting 1, 2, 3, 4, 5, which is fine. Is it time limit exceed? No, it is wrong answer, right? It is telling wrong answer, which is fine. It is not telling time limit exceed. It is actually telling wrong answer. Take 1, 2, 3, 4, 5. You can do this as a flag pursue 1, you can return a, that's fine, right? It breaks this loop, so that doesn't cause any problem. So there is some case that you are missing. So ideally there is some case that you are missing. So let's check from here. So view correct answer. So this is the correct answer. Let's check. So if for a input 9, what is this input? What is this input? Okay, so first is what's the input? Okay, so first is the size and the array size and then the array inputs. Okay. So number of test case, then you have 1901 element. And the array values are numbers. How is array value numbers? Array value should be. Okay, A of I can be numbers as well. Okay, how is it marked as existent? So A of I is telling it is numbers. Now it changes a lot of things, right? If A of I are numbers, let's check for this one, right? So it is telling A of I are not digits, it is can be numbers, and for numbers you have to find out this permutation. Okay, now that is even like this of get expected output. So this is working fine for digits, but in case it is numbers, then it's a bit tricky. So this is the expected output 18, 273, 304. 6. Okay, it does not change it. Okay, let me just cut it from here and paste it over here. I guess it would swap 4, 3 this with 5. Stupid. Now it swaps these two numbers. In case it is numbers, we need to actually check for the first digit, first non-matching digit. Oh, okay. So see, let me explain you this what I did. So let me firstly explain you for digits, then I'll explain you for numbers. Okay, numbers wise, it is little bit more tricky to handle this permutation, but it can be done. See, so what did I do over here? So consider it any digit array, right? So consider it any digits array. So let's say this is your array. So there is no smaller combination that you can make from this. So you just return this array. There is no swaps that you need to do over here. Okay. Now consider this particular array 5, 4, 1, 2, 3. Okay. So there is some combination that you can make from here. What is the combination that you can make from here? So for example, yes. I'm not explaining for numbers. I'm first understand for digits. You'll automatically understand for numbers. Okay. So what we are doing over here? We are trying to find out for 3. We are trying to find out, is there any number which is larger than 3 to the left of it? Yes, there is, which is 4. So what we do is we swap these two. We get 5, 3, 1, 2, 4. Yes, this is our answer. Right. Now we do this for any number and you will always get the correct result. Now, okay. So this was what inner loop was handling. Now, why did I write this outer loop? Why this flag is 0? What are all these things? So see, consider a situation like this: 5, 4, 1, 2, 6. Okay. So for the last digit, when you compare n-1, so let's say when j is n-1, you compare, right? Is there any digit from n-2 to 0 which is greater than this? There is no such digit. So this condition will never satisfy, and this is not going to give you answer. So is there no combination which is smaller than this? No, there is actually a combination that is smaller than this. What is that combination? So that combination is basically you need to compare 2 with all the numbers and you need to find out the larger number for 2. So in this case, you need to swap 2 and 4. So this is your answer. If you try to run this, you should be able to see this is your answer. Let's say 5, 4, 1, 2, 6. And if I get expected output, you should be seeing 4, 5, 2, 1, 4, 6. Okay. 5, 2, 1, 4, 6. So when there is like understood this. So when there is, so the last number will necessarily not have a greater number to the left of it. Second last number might not also even have second last number if it is 7. So this would also not have a greater number to the left of it. Right. So third last number will have in that situation. In this situation, you need to swap 1 and 4. So your answer should be 5, 1, 4, 7, 6. Right. Check it that if I change this number. Okay. So for in that case, you'll get 7. Right. So let's say this is 5. So this is 5 and this is 6. Okay. So you don't get any numbers. So for 5, 6 is not there. Okay. Okay, check. So if this number is 5, sorry, not for 7, if this number is 5, which is also not having any smaller number to the left of it. 5 also doesn't have any smaller number to the left of it. So 1 has a smaller number to the left of it, which is 4. So you swap 1 and 4, right? So for this situation, your answer is 5, 1, 4, 5, 6, see, which is the correct thing. So you just for every digit, you need to check for the left of it. If you get a smaller number, you just swap it and that's done. That's your solution, right? See over here. So what you are getting over here? So firstly, we took n-1, we checked, we took flag is equals to 0, we checked, is there any digit towards the left of it? That means from if j is n-1, so we are checking from n-2 to 0. If j is n-2, so we are checking from n-3 to 0. If j is n-3, we are checking from n-4 to 0. Okay, so that's what we are checking. Now, we'll get the digit which is smaller than this. Here, we are comparing. If there is any digit that is smaller than this, if it is, then we are swapping. Once we do the swap, we are also putting flag equals to 1. Why? Because one swap is done, then we don't need to do any more swap. We don't need to do any other operation. We already got the result, right? So we just need to figure that swap out. If we got that swap correctly, so we don't need to do anything else. We can simply break. We can break and we can find this flag. Okay, understood? Yes, no. Okay, flag equals to 1, we can break. Now this logic is perfectly fine if the A array is digits. But here there is even one more complication, that A array is not a digit, it can be numbers as well. Okay, so A array is not a digit.
Sir,
Uh,
sir, but for numbers also it should be same, na? Because it's an array.
to actually see.
Yes, sir.
Yes, let's that's what I was telling. So let's see. For 18, let's check for 343, 247, 896. Chalo, let's check. So this number is largest. So this does not have any smaller than this. This number is largest. This does not have any smaller. So this has a smaller, which is this. So if I run this, it should swap these two values. It will swap these two values in fact. So you are getting these two values are getting swapped, which is fine. Now there was the previous input that I ran, right? Zero index, it's not going to be a problem, right? For zero index, it's not going to be run. So 0 is 0 minus like I, which is going to break, right? So 0 minus I is -1. So -1 greater than 0. This is not going to work. This is going to break. Okay, let's check in some scenario where this is, let's say 243. So this is smaller. So this is the correct order. You will not see any swaps. Okay. Achha, let's check for this value. It's fine. I guess. So I don't see any problem that's coming. There is some test case in this kind of scenario which is failing, which is like lexicographically larger to be created. Yes.
Sir, instead of 18, we can press 896.
Instead of
18.
18.
Instead of 18, if we place the 896, then what?
Here.
Here.
Yes, there is one test case that I'm thinking of. So basically the test case looks like this. See, when you're forming a number by taking numbers, right? So there would be some number in between, right? So this is not the scenario, I guess. Okay, let me think of that situation. I'll tell you. There is test case that is coming, but I'm not able to figure that out exactly. Chalo. So what the test case is, I'll tell you. See, your number might be like something like this, 1111, which is greater. Okay, but there might be some combination of it.
There is no change.
If it does not change. Okay, so here also, what is our output that we are getting? 1111. So it should be the same. Okay, we are also getting the same result. Let's move this towards end. Let's get expected output. So test case, all those loops are handled, right? So these loops are handled over here. So we don't need to do, we just need to give for any particular array. So it doesn't, okay, it swaps the last and the second last one. If we run our code, it should be also swapping the last and second last one. It is smaller. So what's the problem here? We need to check with this. No, we need to check with this. So it is telling that there are 1901 elements. How do we compare for 91? So this is a very large input. So there is some test case, definitely I can say, for which it is failing. Either the test case is wrong. If our logic is correct, then this test case would be wrong, and we can't anyways figure out this. We have to try to figure the test case out ourselves. So n is 10,000, so at 1900 something is fine. It should be fine. There is some numbers for which this is not working, for which this swap is going to give a larger value, and we have to find that smaller one. Achha, chalo, you can take your lunch break. We can continue this discussion. Meanwhile, I can try to think of that test case which is failing. Yeah. Okay. So take your lunch break and we'll continue this discussion. We'll solve a few more questions as well. Okay. Quickly come back. 15 minutes should be fine. Okay. Yes. Let's come over here. Let me think, and you can come back from your lunch break. Yeah. Hello, everyone. Welcome back. I hope you all have had your lunch. Okay, so I was looking through this. So, okay, let's come back. Yeah. So see, I was looking to this. The solution that we have written is, I guess, it is correct, right? There is no problem in it. It is also going to work for numbers. In case this inputs are numbers, then also it should be working fine. Okay. The problem I see over here is that only thing I can see is time, right? It is 10 to the power 4, so it would be going till n square, which is 10 to the power 8, and that's the only constraint I see over here in getting the solution submitted. Otherwise, apart from this, I don't see any other constraints. Okay, we can check for this logic. What's the name of this question? Previous permutation in a swap. Let me copy this. So this is there in the code as well. And then let's change it to Java. Yes, we are given an array and we have to return an array. Yeah, that's what we have been asked, right? So what we can do is let's check what's the size that is given over here. Here also it's 10 to the power 4, right? So the same size. Now we have written an order n solution, n square solution, right? And it should be a problem. So we should see time limit exceed, something like that. Let's check. Okay. So I see only problem that is here could be is the time limit exceed. Apart from that, I don't see any other problem in our logic. Dot length. It gets passed. Let's try to submit this. So it is giving us the wrong answer for this particular input. Output should be okay. Now this, so this is the input that we were looking for, right? So time wise, I don't think n to the power 8 is going to be fine. This is the problem that's there, right? So 3 when there is duplicate scenario, right? So when there is duplicate, what we need to do? So 3 is not getting, so we are finding 1 is getting sorted with 3. And now we are swapping this. Now in case of duplicate, what we need to do is this should get swapped with the largest. Okay, and this should be valid for a non-duplicate scenario as well. Okay, so I got this. So what we need to do is see. So see what is this solution, and this would be also failing in RCN 3113, right? So let's check for this input, and this is like for which we are getting the wrong output. So the input that we are looking for is this, where there is duplicates. Okay, so in this case, when we try to get the expected output, we'll get we should be getting 1313. Okay, now this is like the largest value that you can form with one swap. Now what we are doing is we are trying to compare 3. Is there any larger values? No. So we try to check with 1. Is there any larger value? Yes. So we swap 1 with 3. So we get 1133, which is the wrong output for this. Okay. So this was the test case that we were looking for. When there is duplicates, this would be the situation. So in case of duplicates, how do we handle it? I think we can just tweak our logic to handle this. So in case of duplicate, see what you need to do is to get this swap value for this number. So let's say firstly you have to find out the number which is okay, I can write the same logic in a reverse way. Think of this in this way. So firstly we have to find a number such that it is greater than its next number, right? So if this is the situation, then this is the first place which this is the number with which you have to swap. If we try to check it in this way, right? If you try to check on the reverse end, this is the number which is like the larger which is larger than its previous number. This is the only number which is larger than its previous number. This is the first number which you have to swap. With what number you have to swap? You have to swap it with the number such that okay, you have to find out the first number which is smaller than this in the right. Yes, first number smaller than, so all the numbers are smaller. Even checking smaller. So in case of equals, the first number which is smaller than this, if you find any other number which is smaller than this current number, you swap it with that. Otherwise, you swap it with this particular number. Okay, so it's one. So don't swap it here. Okay, so this thing we have to check it from the right. Okay, this is the scenario that is breaking. So this is fine for non-duplicates. For duplicates, it would be breaking, right? So for duplicates, what you need to do is, see, we need to find out two numbers. Okay, so let's call it the first number is F and the second number is S. Okay, these are the two numbers that we need to find out. Okay, first number is F, second number is S. So let's say this two stores index, right? For simplicity, this two will store index. So both of them are initially -1. Okay, not valid index. So at the first index of this, so for any number, right, for any logic that we have written, so we can start our array from the end and we can find out one such number which is not following this. So for example, the first number is, we are going to start from n-1. We are going to check for I greater than or equals to 0, I minus minus. So we're going to decrease it. And what we need to find out, so see, we need to find out one such place. So this is always going to be in this sorted order. This last part of the array was always in sorted order. We need to find out one such number such that if a of I minus 1, this is greater than a of I. Okay. No, a of I minus, yes, a of I minus 1 should be greater than a of I. Then this is our first number, right? This is the number which we have to swap I minus 1 and we can break. Okay. So what we did, we found out the first number, which is this 3. In this situation, we'll get 3. See, check. So we'll check I minus 1 with I. So this is not greater. This will not satisfy. I minus 1 with I. This is also not greater. This will also not satisfy. I minus 1 with I. This is greater. This will satisfy. So we will subtract this. Okay. We'll subtract this. I minus 1 with I. Will get this as result. Okay. Acha. Next what? So we got this as result. I minus 1 subtracted with I. This is the first number. But the second number, we have to find out the number to the right of this. So that is going to be our second number. Okay, if there is no such first number, if the first number is still equals to -1, you can return array from here, right? Array from here. Okay. If this number is -1, then you can return the array from here. If this number is not -1, then we have to find out the second number and swap it. Okay. In which situation this will never satisfy? If the array is sorted in ascending order, right? If the array is sorted in ascending order, let's say this is 1. Okay, so this is sorted in ascending order. There is no swaps you can do. So you can keep on checking any two consecutive i's. You will not get any such value. So for the swap, so your f will still be -1. So you can just return from here. Now, if this is there, you'll find a value which you need to swap. Now, what you need to do is you need to start from the f plus 1. So for example, this I loop will start from f plus 1. You need to check from there, and we need to go till all the way till n. And we can increase it by 1. Okay. Okay. Now here, okay. So we got this. So now we have to find out one such number which is greater than a of f. Right? If we find that number, if that is greater than a of f, we are done. Right? So if a of I, this is greater than a of f. This is greater than, or in case of equal, what we need to do. This is equal. This is equal as well. So let's check. F I is greater than 3. This will be the first transition. Okay, this will be a transition position, and we'll get that number. Yes. Okay. So the second number. Let's think of this, right? So you have to find out one number to the right of it, which is smaller than this. So if a of I is smaller than a of f, then you need to store this. Second is I, and you can break. And finally, at the end, you need to just swap them. Temp is equals to, let me validate this. A of f, A of f. It should be fine. Run this logic. It should be 1313 that we should be getting. 1313 is the number that we are getting, and let's check it for the other inputs. So 1, 2, 3, 4. We should be getting 1, 2, 3, 4 because here the first condition will not satisfy. We'll just return from here. The pounds. 4 length is fine, right? Are we checking anything? Oh, we are checking I-1, so this is 1. I'll explain. I'll explain the same logic, just I've written it in a little bit different way for handling the duplicate scenario. Okay, duplicates case mein there is one thing that we are missing over here. Okay, rest all is fine. Okay, so let me just submit this. क्या problem है? Let's check what else did I miss. Excellent. If I is greater than equal to this, simply putting it, or else what we can do is if yeah, yes, that's I. Now let's try to run this. We have to this. No, it's okay. Got it. Chalo. So see, I'll explain this again. See, so this solution initially was correct, but there was one problem. Okay. So problem क्या था मैं बता देता हूँ पहले. ठीक है. Let me explain the problem first. So check for this input. ठीक है. So everything was fine. So check for this input, you'll understand. So every other input is going to work fine when you don't have duplicates. In case of duplicates, right? So for example, this is our logic. Okay, this is our code. So in case of this duplicate, what our first code is going to give us? This first code, what it will be giving us? Forget about this code that I wrote over here. Okay. So what is this logic going to give us? If I run this, you'll see the output is okay. Did I miss something? Okay, there is returning. Okay. So if I run this, you will see the output is 1133, right? 1133. Yes. So it is fine. What we are checking is we are checking for the last number. We are checking whether there is any larger number than this. No. We are checking for this number. Is there any number larger than this? Yes. So there is a larger number than this, and we actually swap 1 and 3. Okay. So we are swapping 1 and 3. And we are getting 1133, okay, which is our solution. But is it correct? Let's check. So what I told you, what is this question expecting? So this is the solution that we are getting, 1133. And between this and this current number 1331, there should not be any such combination of this that could be formed by one swap of this. Okay. Is there no combination of it? Actually, there is. So if so we can get this solution 1313, which can be formed even by one swap, which is swapping these two values, and you'll get this number, right? So by swapping these two values, you can form this number, like not this, and this number is larger than this. So you actually get one solution in between, which should be your correct solution, and we are printing this. So our solution is wrong in case of duplicates wala logic. Okay, understood where our solution is going wrong. What was the test case where our solution is failing? So when you don't have any duplicates, your solution is going to work fine. But when the case you get a duplicate, the code is failing. And this is that test case example of that. Now, how do we handle this? So let's look what is the thing that is changing. So in case of this current logic, what we have done is, so we are checking for the last number. Okay, so we check for the last number. Okay, we pick the last number. And we try to check, is there any number larger than this? No. We check this number, we check any number larger than this. Yes. So we swap it. So ideally for duplicate, we should not be doing, if this number is equals to this previous number, if this number is equals to its previous number, we should not be checking for this number. Okay. We should go to its previous number and we should be checking for this, and we should be swapping these two values. Okay. So I guess this small change, doing it over here might work, might still fail for some test case. But let's try this. Okay. So if the I and I minus, so for J that we are trying to swap, so if J is, so if A of J is double equals to A of j minus 1. If j minus 1 exists, right? If j minus 1 is greater than 0, and then this is true, then we can simply continue. And we can try to run for this. It will ultimately check for 1. So we are getting 1313, which is fine. If I submit this, is there any other test case that would be failing in this situation? Duplicate to handle who hai? Okay, it should be equal to 0 as well, right? Yahan pe equal to miss ho gaya. So there was one equal to that was missing. So it's fine. Now, is there any other test case that is missing in this logic? Let's check. There is some test case which is still missing. Okay, and also this is taking more time, right? So that's why I guess यहाँ पे ये debug करना भी थोड़ा सा problematic हो. चलो let's check that what is this failing for in lead code. So it will give us the test case, right? So some small test case which if we can look, we'll be able to know. I try to run this. I guess we get all the correct solutions. Let's try to submit it. If we get a smaller test case, we might. This is a very large one. So which two numbers is it swapping? Okay, there is some duplicate case that would be difficult to handle using this. Let me explain you the easier logic that I've written, right? So here there is some duplicate which would be again, this would not take care of all the duplicates that's there, right? There can be multiple ways of having duplicates. Okay, so let me explain what I have done over here. See, the first number that we are picking to swap was correct, right? The first number that I'm telling that we are picking this number which is not following this order. So see, what we are doing is the last number we pick and we try to find out the number that is larger than this, right? And that is the number we are actually, that is the first number which we want to swap. So this logic is correct, right? So this is the number that we want to swap. So I minus 1. So if there is any I minus 1 which is greater than I, right? So I pick this number. So if this is like smaller, this is greater than this, I minus 1 is greater than this, we got that value, right? So this is the number that we have to swap. Okay. If this is not true, then we'll check for these two, right? So we'll check for these two. We'll get the solution which one is not following the order. That is the correct. If this, we'll check for these two. So here this is not following the order. So we got 3. So 3 is the value that we have to swap. In the previous logic also we'll get 3. There we are getting it in n square. Here we can simply get that in order n. Okay. Understood how we are getting this value, the first value for swap. So you are just checking with the previous number. If it is greater than A of I, then that previous number is the number which we have to swap. Okay. And here we are just writing one loop to get this, because see, if this is not satisfied, then this number is smaller. You can simply find out the number larger than this, and that would be the answer. Okay. So any such number that is not following the order, that is the thing that we have to figure out. Okay. No, can't. Acha. See, over here in this particular example, what we have to do is we have to find one such logic like this, right? One such pair like this from the end. From the end of the array, we have to find one such pair where this is not following the order, where this is not following this order, where like this is, so last part is sorted. Okay, think it in this way. As a socho. Chalo, I'll tell you this. Chalo, ABCD kare bata. Okay. So let's say the digits are 4, 5, 1, 2, 3. So so in this particular element, what we were taking? We were taking 5 as the first digit, and we are telling, okay, we can swap it with what digit? With which digit we were wanting to swap 5. So we were swapping 5 with 3. Yes. So we are swapping 5 with 3. So we are getting 3, 1, 2, 5. Yes. So we are getting, this is the correct result. Now, how did you get 5? So first thing is forget about 3. How did we get 5? So 5 is one such number which does not follow this order, right? So this was in sorted order and this is not following that order. So we have to, so we got this particular number. Okay, 5 is the number that is not following this sorted order in which this 1, 2, 3 were there. So 5 is the number that we have to swap. Okay. So how did I get 5? So we just started from the end. We checked is 3 and 2 is this correct order? Yes. Is 1 and 2 this is the correct order? Yes. Is 1 and 5 is this the correct order? No. So this is not the correct order. So this is the number which can be swapped. Now we have to form the largest number using this. So how will you get the largest number? So if you swap it with the largest digit that's there in the right side of it. If you swap this number with the largest digit that's there in the right side of it, you'll get the largest number, which is this in one single swap. Okay, understood? So this is the largest digit that you got from here, which is out of order. So these are in the correct order. This you cannot form any combination in this, which is like smaller than this. So no matter, so for example, if you keep 4 and 5 fixed, okay. So take this example. This is like easy to understand from here. So if you keep 4 and 5 as fixed, no matter whatever you do with this, right? No matter whatever you do with this, you cannot form a number larger than 1, 2, 3. Sorry, smaller than 1, 2, 3. You cannot form a number smaller than 1, 2, 3. So there cannot be any combination using these three that you get a smaller number. So overall number cannot be smaller if these two digits are fixed, and you cannot swap these digits to form a smaller number. So you cannot get a smaller number than this. Understood? So that's why this number, this first digit which is out of order, swapping this will give you the correct result. Okay, understood this part? And this would also be true for the duplicate scenario as well. Okay, understood why we are taking 5 in this way. So the first digit that is not following that sorted order, if this rest part is sorted, right? So this is the first digit which you can swap to get the number which will be which can be smaller than this, right? No matter, you cannot swap any of these digits and make a smaller number. So that's why I found this digit out. How did we find? We compared any two consecutive digits. If this digit is smaller than this, okay, then you cannot take this. If this is smaller than this, you cannot take this. If this is smaller than this, you cannot take this. But if this is not smaller, I-1 is not smaller, you can take this digit. Okay. Now with which digit I have to swap it? You have to swap this digit with the largest digits to the right, towards its right. And in case of duplicate, it is like the first smallest digit. Okay. So how can we handle this? यहाँ पे दो conditions है. Either like in case there is no duplicates, you swap it with the largest digits towards the right. Okay. So, and in case there is duplicates, you swap it with the first, what am I saying? You have to swap it with the digit that is larger than this towards right. And in case of non-duplicates, you have to swap it with this particular digit. See, यहाँ पे दो cases है, and our code should work for both the cases correctly. Okay. So in this case, 5 should be swapped with 3. In this case, 5 should be swapped with 1. So let's check whether our logic is working fine in both the cases or not. So for this, it is working fine, right? So for this, it is, we are getting this. So let me just uncomment this part. Okay. Now if finally f is -1, that means we did not get anything like this. So we can simply return, right? If f is -1, that means all the numbers were like all the previous numbers were smaller than the next number. So for example, this was the array 1, 2, 3, 4, 5. So this condition will never be true. I-1 is never greater than I. So for any I-1 pair, I-1 is never greater than I. So this is going to be never true, and this condition is never going to break the loop. Okay. Understood this? Yes, no. Okay, so why we returned A. Now, what's the first value? What's the first candidate with which you can swap it? So f+1. f+1 is the first number with which you can swap it, right? If f+1 is the if f+1 can be the first number, you will always swap it towards the right. You'll never swap it with the left. So if f is your digits, so let's consider this 1, 2, 3. So if this is f, you will always swap it with the right one. So s can be anything, like s can be here, it can be here, it can be here. Now for this logic, what we are checking, just check over here. So if a of I is greater than equals to f, is a of I, so we are starting with f+1. If a of I is this greater than equals to a of f, which is 5, no, this is not. So we are not breaking, right? If this is greater than this, we'll simply break, right? In that situation, we'll break. Otherwise, what we'll do is we'll check this condition. If this is greater, that means if we find a 6 or something over here, then we'll simply break. Okay. Okay. So now this is not true. So what we do is we check over here. A of s, which is A of s is this one. Is 1 less than 1? So this is like a redundant check. This is going to be false. Okay. So let's not worry about this. We've already stored 1. Okay. Let's check for the next number. So if 2 is greater than equals to 5, is this true? No, this is false. So check this condition. Is A of s, which is 1, 1 is less than 2? Yes, this is less than 2. So you don't need to swap it with this. We can swap it with 2 and we can still get a we'll still get a smaller number, right? Also, we'll get a larger number than the previous swap. So we can that could be the possible best candidate for result. So for example, swapping this would give you 2, 3, and swapping this would give you 2, 1, 5, 3. Yes. So which one of them is greater? Obviously the second one, right? Second one is obviously greater one. So this can be our solution. This is smaller than this. So this will be our solution. Got it? Why we'll pick this one as solution? Because swapping it with 1 will give us a smaller number. Swapping this with 2 will give us a larger number, right? Similarly, swapping it with 3 will give us an even larger number, right? So next condition, what we are checking is 3 greater than equals to 5. No, this is also false. So we check this. Is 3 current solution that we have 2 is 2 less than 3? Yes, 2 is less than 3. So we'll take s is equals to I, which is 3. We'll swap it with 3, not 2. Okay. Understood? Yes. So finally we get this will swap with this. How this duplicate case is getting handled? Let's check for the duplicate ones as well. So when this is duplicate, we'll get this as f. Okay. So just look for the first logic. This is on order. This is in order. Let's check. A of I is greater than. So is this greater? No. Is this greater? No. Is this greater? No. Is this greater? Yes. So we'll get this one as f, I minus 1. Okay. We got a f, so we'll not break over here. We'll come to this part. Okay. Now look what we are doing over here. So in this situation, we are checking is f plus 1. So s is equals to f plus 1. So s is equals to this particular s is over here. Okay. Now we check is a of I greater than f. So a of I is this particular number. Is 1 greater than 3? No, this is not true. They're greater than equals to. This is not true. So we come over here. We check is s less than s, which is 1, it is less than 1. So this is also false. So first one is redundant check, right? Next iteration I is over here. So what we are checking is 1 greater than equals to 3. This is again false. So we don't do anything. Here we check is 1. Okay. Here we check is 1 less than 1. So this is not true again. See, in the duplicate case, this 1 compared with 1 is not going to be true. So see, here we are actually in this case, we are actually going to swap. This is not going to, s is not going to update to here, right? So we are going to swap actually 3 with this particular ones, which is going to give me 1, 3, 1, 3. Instead, if I swapped this with this particular one, we would have got 1, 1, 3, 3. So this is obviously a smaller number and then this. Right? So in case of duplicates, we always swap it with the nearest one to get the largest number. Right? So we are swapping it with the nearest one, we'll get the largest number. So this condition will not be satisfied. So we'll not swap this. Next iteration, we'll check 3 greater than equals to 3. Yes, 3 is greater than equals to 3. So we are breaking this loop. We are breaking this loop and we are not checking this because this condition would have satisfied, but we broke this loop. So we are not checking for the duplicate case. So 3 greater than 3, this condition we are not checking. We come out of the loop and then we swap this f with s, which is these two values. So in duplicate case also, we are getting the correct swap and not swapping it with some other value. Okay, understood? I know there was 2 edge cases and that could be handled differently. Now, this was the cleanest way I found to handle this duplicate and non-duplicate scenario. If there is no duplicates, that logic is fine. But in case of duplicates, it's going to be a lot of problems. So handle with that. Okay, now if you submit, this is going to be fine. Yes. This is one such logic you have to do dry run. This part is easier, even like I'll say, this is at least somewhat easier to understand. This is difficult. I guess this condition you won't get anywhere greater. You will just get equal to. So if I just try to do it with equal to, should be fine. Will we get anything greater than this? We won't get anything greater than this towards the right. Will we get, there is something greater. There can be a greater. So there can be a test case where it will be greater as well. What would be that case? So you have a greater number towards right. 0.5 will be greater than f. That is, that can be. So this. That is the situation. Okay, got it. There can be a larger number which is greater. So this would fail for like multiple multi-digit number, right? Let me paste this logic in GDB. Try to do a dry run yourself. Try to see the logic. Okay, yeah, you'll be able to understand. Take these examples, the numbers examples that I gave you, duplicates, non-duplicates ones. Okay, this is question permutation in one swap. Okay. ओके सेकंड पार्ट हिंदी में बता दें। देखो सेकंड पार्ट में क्या करना था ना हमें, देखो फर्स्ट पार्ट में तो नंबर मिल गया, अब उसको स्वैप करना है, किस नंबर से स्वैप करना है वो वेरी करेगा जब ये, इसी ने क्यों राइट, देयर इज दिस शुड बी मार्क्ड एज मीडियम राइट, देयर वाज अ लॉट ऑफ एज केसेस। सो सी वो यहाँ पे क्या करना है, यहाँ पे बेसिकली हमें एक ऐसा नंबर फाइंड आउट करना है जिससे स्वैप करना है। अब जब इक्वल होगा ना, जब डुप्लीकेट होंगे, तो डुप्लीकेट के केस में सबसे पहला नॉन इक्वल नंबर होगा जो लेस देन होगा वो होगा। जैसे इक्वल नंबर मिल गया या ग्रेटर नंबर मिल गया, वहां पे हमें ब्रेक करना है, ठीक है। और इन केस जब ये डुप्लीकेट नहीं है, तो फिर डुप्लीकेट नहीं है तो फिर हम ये वाला कंडीशन कभी सेटिस्फाई नहीं होगा, ठीक है। और हमें वो नंबर फाइंड आउट करना है जो इससे छोटा है, ठीक है, टुवर्ड्स द राइट। सो ये क्या फाइंड आउट कर, लेट्स फॉरगेट अबाउट दिस, व्हाट विल दिस फाइंड आउट, ये क्या फाइंड आउट करेगा। अगर f+1 से स्टार्ट कर रहे हैं एरे और हम चेक कर रहे हैं इज देयर एनी नंबर ग्रेटर देन दिस, तो हम एक ऐसा नंबर फाइंड आउट कर रहे हैं जो कि लार्जेस्ट इन द राइट साइड ऑफ द एरे, राइट, इन द स्टार्टिंग फ्रॉम f+1 to n विच इज द लार्जेस्ट नंबर, हम वो फाइंड आउट कर रहे हैं, राइट। ओनली केस हमने यहाँ पे क्या ब्रेक लगाया कि इफ we get any such number which is larger than the number which we want to swap, हम ब्रेक कर रहे हैं, ठीक है। क्योंकि अगर डुप्लीकेट हो गया, जैसे 3 और 3 आ गया, सो 3 और 3 को हम स्वैप नहीं करेंगे, 3 क्योंकि ये 1 से स्टार्ट करोगे तो लार्जेस्ट नंबर 3 मिल जाएगा, तो हमें 3 के साथ स्वैप नहीं करना। हमें अगर इक्वल मिल गया तो हम ब्रेक करेंगे, और अगर ग्रेटर भी मिल जाएगा तो भी ब्रेक करेंगे। ऐसे कोई बड़ा नंबर होगा तो ब्रेक करेंगे, वो लाइक जो नंबर वाले केसेस है ना वहां पे ये फंसेगा। यहाँ पे डिजिट्स वाले केस में ये ग्रेटर नहीं मिलेगा, इससे इक्वली मिलेगा हमेशा। अगर ग्रेटर होता तो कुछ और लाइक कंडीशन भी सेटिस्फाई होती, ठीक है। सो स्टार्टिंग में एफ ही हमें डिफरेंट मिलता, तो बट ठीक है, नंबर्स वाले केस में ये डिफर करेगा। सो नंबर वाले केस में हमें उसके साथ स्वैप करना है। गॉट इट? गुड मॉर्निंग। ओके, अंडरस्टूड, क्लियर, ठीक है। So I pasted the logic, you can see through it. Are there any other question that's remaining? कुछ और पूछना था, एक डाउट और था यहाँ पे मैंने ओपन करा था, पास्कल ट्रायंगल, चलो इसको क्विकली कर लेते हैं एंड देन वी कैन कॉल इट फॉर द डे, ठीक है। दिस इज इजी। अच्छा, एरे लिस्ट में नहीं रिटर्न करना, सॉरी, आई विल नॉट रिटर्न इट इन एरे लिस्ट। ये क्या एरे लिस्ट ऑफ एरे लिस्ट बोल रहा है, ठीक है। मैक्सिमम यू डू इट राइट, दैट यू ऑल नीड टू डू टुडे, आई डिड नॉट गिव यू टाइम, सो मैक्सिमम यू ऑल ट्राई राइट, लाइक दैट मीच क्वेश्चन यू ट्राई, ठीक है, दैट ऑल थिंग्स यू ट्राई। So I'm removing this array list since we don't know it. I'm just calling this function and we'll print it ourselves. Okay, we want to do it tomorrow. Test case problem, which test case? In this question? Is there any test case? No. Maximum minima. Okay, maximum minima. Maximum I'll discuss tomorrow. The maximum minimum there is there is a lot of ways to solve it. Think through the 2D arrays way that I gave you, right? Think it like multiple one-dimensional arrays. How will you solve it? Think it like how can you traverse a one column in the array? How can you traverse one row in the array? Spiral matrix is also same thing, right? How can you traverse one column? How can you traverse one row? Our cache is exhausted. So shall we do this or shall we park it for tomorrow? whatever you all say. Tomorrow. So let's okay, do one thing, remove all the this. I'll explain, I'll give you idea. Okay, I'll give you idea how you can solve this question. So you can take a 2-dimensional array. Okay. So what is the size of 2-dimensional array going to be? You can take a varying 2-dimensional array where each array is like 1 length, 2 length, 3 length. Can you take an array like that? An array having the first row is 1 size, second row is 2 size, third row is 3 size, fourth row is 4 size. Your array lengths are going to just increase by 1. How many such rows you will have? You have such 3 rows, right? So you can create an initial 2-dimensional array having 3 rows. So let's say you are given just an n. Can you create a 2-dimensional array having that many rows? And a square bracket equals to new int n rows, and you don't need to mention the columns. Okay. Can you create this with varying columns? So first row is going to have 1, then you are going to have 2, then you are going to have 3, then you are going to have 4. Okay. So you got the number of columns in it. Now what you need to do? So the first one is fixed, it is 1. Okay. In the second one, the first and the last value is going to be 1. Third also, the first and the last value is going to be 1. These two values, so first and the last value is always you have. You always have first and the last value. So for any array, the first and last value is always 1. Okay. Just take the first array of 1 size, put it as 1, and for remaining array, the first and the last value is 1. Okay. Acha. And the remaining n minus 2 values, how are they calculated? They are nothing but the sum of previous 2 values from the previous array. So from the previous array, you can start with 0. You can start adding 0 and 1. So in this case, you are adding 0 and 1. In this case, you are adding 0, 1 and 1, 2. In this case, you are adding 0, 1, 1, 2 and 2, 3. See? Got it? So now does it look like a pattern that you can follow to print this? Yes. Sure. Okay. Try this. Try to solve this. Okay. I think we can call it here for the day. You have a session at 4 o'clock for soft skills. Do attend that. Okay. Solve all the 2D arrays questions. Do you have a contest today? Right. Try to do it well there. I am expecting you all will do very well. I don't have any doubts on that. Yes. So I don't have any doubts you'll not do well in contest because we have done enough questions till now, and this is like the first contest that you are getting, right? And it's like already too many days we are learning. So you are already very much comfortable with programming, coding, right? So just try to take your time, solve the easy ones. Then yeah, tomorrow class will also be at 11. Yes, it's also 11. Okay. Hello. Thank you, everyone. See you all tomorrow. Bye-bye. Good night. Not good night. Hello. Bye-bye. Have a great day. Very well. Okay. No, good night. Yes. Okay. Hello. Bye-bye. Take care.
Sir, notes.
Okay, sorry, I did not paste it here. Let me paste the notes over here. I'm sharing it, so you'll get it right away when the recording gets converted. Along with that, okay, I pasted the notes in chat. So for those of you, please paste it in your WhatsApp group so others can have immediate access. Okay.